We're going to start our study of Chapter 2, Section 9. So that's Section 2.9. As always, whenever we start a new section, we always start with the learning target. The learning target for today is to use powers and exponents in expressions. So we've got a couple of terms we need to do. We first of all have to know the powers represent repeated multiplication. So for example, if I've got 7 to the second power, that's equal to 7 times 7. There's two of them. So 7 times 7 is 7 squared. Our case in that case would be 49. Another term we need to know is the base. The base is the number raised to a power. So in this case, it was the number 7. In this case, it's the number 3. In a power, the number of times the base is used as a factor is the exponent. So looking back up here, it was 2. Here it happened to be 2 also. All right, let's do a little bit of practicing here. If I've got 1/3 times 1/3 times 1/3 times 7 times 7, I'm going to do a little bit of grouping here. I'm going to group some like terms together. I've got 1/3 times itself 3 times, so that's 1/3 to the third power times 7 to the second power. Looking at this problem, I'm going to again group like terms together. I've got 2 times 2 times 2 times 2, that's 2 to the fourth, times 5 times 5, times 5 would be 5 to the third. So 2 to the fourth times 5 to the third. Here I'm going to group some like terms together, but I want to make sure the letter P times the letter P times the letter P times the letter Q times the letter P times Q times Q. Well, if I group the like terms together, I've got P times P times P times P, there's 4 of them, times Q times Q times Q. So in this case, it is P to the fourth power times Q to the third power. Similar idea down here. I'm going to collect my like terms together. I've got X times Y times X times X times Y times Y times Y. So I've got X times itself 3 times, and I've got Y times itself 1, 2, 3, 4 times. So I've got X to the third times Y to the fourth is an equivalent statement. An important concept that we need to make sure that we understand: any number raised to the 0 power is equal to 1. Any number raised to the 0 power is equal to 1. That's a definition that we need to have down pat. Another definition that we need is to say any non-zero number to a negative exponents. We need to cross out the word is here. To a negative power is the multiplicative inverse. It is the multiplicative inverse of the to the nth power. So for example, 7 to the negative 3 power is really saying 1 over 7 to the third power. 7 to the negative third power over 1, it becomes, I move the 7 to the third power to the denominator, and I move the denominator up, and it becomes 1 over 7 to the third. Same exact thing here. I have to move this to the other part of the fraction, and it's 1 over x to the nth power, I've got to evaluate 3 to the 5th, 3/4 to the 5th power, 3/4 to the 5th power. That means 3 over 4 times 3 over 4 times 3 over 4 times 3 over 4, and I have to do this 5 times, 1, 2, 3, 4, 3 over 4. Another way to say that is 3 to the 5th power, because there's 1, 2, 3, 4, 5 of them, over 4 to the 5th power. 3 to the 5th power, if I do my math there, use a calculator, I get 243. And 4 to the 5th power is 1080. 224. All right, similar problem here. I've got 3/5 to the third power, so that's 3 to the third power over 5 to the third power. 3 to the third power is 3 times 3 times 3, or 3 times 3 is 9 times 3 is 27. 5 to the third power is 125. Evaluate 3 to the negative 7. First of all, I want to rewrite it as 1 over 3 to the 7th power. If I evaluate 3 to the 7th power, I get, using calculator, you get 2187, 2,187. If I do the same thing down here, instead of writing 2 to the negative 5, I'm going to write it as 1 over 2 to the 5th power. If I evaluate 2 to the 5th power, use my calculator to save a little bit of time, 2 to the 5th power is 32. I'm going to plug some numbers into my equations. I'll plug 4 in for x and 2 in for y. So I get 4 to the 3rd power times 2 to the 5th power. 4 to the 3rd power, if I work that out, it's 4 times 4 is 16, times 4 is 64, times 2 to the 5th power, 2 to the 5th power is 32. And if I take 64 times 32, I get 2,048. I'm going to do the same thing here. I'm going to plug 3 in for the x and 4 in for the y. So I'm going to get 3 squared times 4 to the 4th power. 3 squared is, of course, 9, times 4 to the 4th power is 256. And it quit working. I don't know. I don't know what happened there. We had a little bit of a glitch. As you can see, I'll go back and redo this problem. I plug in 3 to the squared, so it'd be 3 squared, which is, of course, 9. And then I plug in the 4 in for the y, and I get 4 to the 4th power. 9 times 4 to the 4th power, if I use my calculator, is 256. So I've got 256 times 9. And I get 2,304. 2,304. Thank you.